Good morning, dear students. I am Dr. B.K. Murugunde, Assistant Professor, Department of Physics, STM College of Engineering and Technology, Hyderabad. Today I am presenting my laboratory experiment on logic gates. The aim of the experiment is verification of truth table for AND, OR, NOT, NAND and NOR gates, construction and verification of basic gates by using universal gates. The apparatus used in this experiment is ICs, 5-volt power supply, LED and single strand wires. What is logic gates? The logic gates are the electronic circuits which perform logical functions such as addition, multiplication, inverse, etc. It may have two or more inputs and only one output. The procedure of the experiment is connect the IC into the breadboard and connect positive terminal of the power supply to the 14th of the IC and 7th pin to the negative terminal of the power supply. Connect the output pins of the logic gates of an IC to the positive terminal of the LED and negative terminal of the LED is connected to grounding. Apply the various input combinations and observe the output at the LED and also verify the truth table for all the gates. This is the pin diagram and truth table for the logic gates. In this pin diagram, there are 14 pins in an IC, 7 pins on the lower side and 7 pins on the upper side. And this notch indicates the first pin. Okay? These 1 and 2 are the inputs, 3 is the output. Output is connected to positive of the LED and negative is connected to grounded. And these are the input combinations A, B and this is the output. If I want to apply 0, 0, connect inputs 1 and 2 to the 7th pin or ground. And if I want to connect 1, 1, connect 1 pin to 14th pin and 2 pin to 14th pin. These are the input combinations and whatever the output you will get from that logic gate, that is connected to the LED. If you get the output is 0, then LED will not glow. If the output is 1, then the LED should glow. First gate we will study, that is AND gate. The AND gate produces an output 1 when all the inputs are 1, otherwise the output is 0. The AND gate is just like in multiplications, 0 into 0 it's 0, 1 into 1 it's 1. Okay, and the IC number of the AND gate is 7408. This is the IC. It has 4 gates, 1, 2, 3 and 4. 1 and 2 are the inputs, 3 is the output, output is connected to LED, LED negative is connected to ground. Whenever the inputs you put 1, 1, the output is high, that time only the LED will glow for AND gate. For all other combinations, LED will not glow. This is the actual IC of the AND gate, IC number 7408. Now we are moving to OR gate. The OR gate produces an output 1 when any or all the inputs are 1, otherwise the output is 0. The OR gate shows the addition performance, that is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 1. For all the any one of the input is high, the output is high. If both the inputs are 0, the output is 0. This is the pin configuration of the IC 7432. 4 gates, 1, 2, 3 and 4, and this is the actual IC of the OR gate, that is 7432. For this experiment we are performing the student. Now we are studying the logic gate experiment. The aim of the experiment is verification for truth table for AND gate, OR gate, NOT gate, NAND gate and NOR gates, and also construction and verification of basic gates by using universal gate. Now we are demonstrating the OR gate experiment. This is the block diagram of the OR gate and this is the truth table of the OR gate. In the block diagram we have 4 gates, Y1, Y2, Y3 and Y4, and 1 and 2 are the inputs and 3 is the output. Here we are connecting output to the LED of the positive terminal of the LED and negative terminal to the 7th pin of the IC, and 14th pin is connected to plus VCC. Here we have to consider plus VCC as 1 and 7th pin as 0, and we have to apply inputs at 0, 0, 0, 1 to the 1 and 2 pins, and we are getting the output through the third. If my output is high, the LED will glow. If my output is 0, the LED should not glow. This is the IC of OR gate, that is 7432. Here at the lower terminal we have 7 pins, and upper terminal we have 7 pins. In the lower terminals 1 and 2, that is red and grey are the inputs and white is the output, and this white is connected to the positive terminal of the LED and negative terminal of the LED is connected to 7th pin. And for the power supply, the 14th pin is connected to positive of the power supply and the negative terminal is connected to 7th pin, okay, or from 7th pin we are connecting to the negative of the power supply. Here we are supplying a 5 volt to the positive and negative terminal of the IC. Initially, first we have to verify the OR gate. First we connect 0 pin to the ground, means first we apply A0 B0 to the Y1 gate, means here A is red and B is green. Now I am connecting A to 0, means to the 7th pin, and B, the LED is already glowing. If I connect B to the 7th pin, the LED should not glow, means the output should be 0. See here, if I connect B terminal to the 7th pin, the output is 0. If I remove it, again it is glowing on. If I connect it, it will go off, means if I connect A and B terminal to the 0, the output is 0 for OR gate. This is first condition. If A is 0, B is 0, the output of the OR gate is 0, means the LED is not glowing. Now I will move to the second combination, that is A is 0 and B is 1. Now I will take green terminal. Now it is glowing. Now I will connect this pin to the 14th pin. See here, if I connect A is 0 and B, that is green terminal, is if I connect it to 14th pin, the LED is still glowing. Now I will move to the next combination, that is 1 0, means connect A terminal to 1 and B to 0. This is 0 B terminal and A terminal I am connecting to 1. See here, now still the LED is glowing. It means that the OR gate is working properly. Now I will go to next combination, that is 1 1, means I should connect both A and B both to the high terminal, means red and green terminal. See here, now this is the last combination, that is 1 1. I am connecting A, that is red wire, and green, that is B, both to the 14th pin, and the third pin I am connecting to positive of the LED and negative terminal to the 7th pin, and from the same negative terminal I am connecting to power supply negative, and the positive terminal is connected to 14th pin of the IC. See, now I will, both are 1 1, then the output is high. I will show once again. If both are 0 0, then the LED should not glow. I will check it once again. See, I am connecting two wires, that is red first A wire I am connecting to high here. The LED is still glowing. If I connect B to the 7th pin, the LED is not glowing. Thus, it is verified that when both are 0 0, the output is 0. If any one of the input is high, the output is high. Thus, the OR gate is verified. Similarly, we have to verify for Y2 gate, Y3 gate and Y4 gate, and we have to note down the output. Similarly, we have to do same experiment for the different gates, that is AND gate, NOT gate, NAND gate and NOR gates. That is NOT gate. The NOT gate is also called as a complement gate. Whatever the input you are giving, either 0 or 1, it will give its complement. Okay. And also the NOT gate is called as an inverter gate. It produces inverse. If you give 0 as input, it produces 1. If you give input as 1, it produces 0. This is the pin diagram of the IC number 7404 for NOT gate. Here we have 6 gates total. Here only one input, one output. Output is always connected to through the LED to see the results. Okay. In this experiment, for all the gates, we have to verify the logic operations, that is 0 and 1. Okay. This is the actual IC of the NOT gate. If you give 1 here, the output is 0. If you give 0 here, the output is 1 for the NOT gates. Next, we are going to NAND gate and NOR gates. Here, the NAND gate and NOR gates are called as universal gates because by using this NAND gate or NOR gate, we can construct the basic gates such as AND, OR, and NOT gates. That's why this NAND and NOR gates are called as a universal gates. Okay, and first one, the NAND gate pin IC number is 7400. The NAND gate is actually a series of AND gate with NOT gate. Its output is 1, any or all the inputs are 0. If any one of the input is, both the inputs are 1, 1, the output is 0. If any one of the input is low, the output is high. If both the inputs are high, the output is 0 for the NAND gate. You can see here, the NAND gate is nothing but the inverse of AND gate. In the AND gate, we are getting high only in this region. 1, 1 is there, then only we are getting high. All others 0 we are getting in the AND gate. But here it is inverse of AND gate, means all other case we are getting the high. Only when 1, 1 is there, we are getting the 0 for the NAND gate. This is the pin configuration of NAND gate. AND gate is not at here, 0. Okay. Here 1 and 2 are the inputs, 3 is the output, 7 is plus VCC, and 14 is plus VCC, 7 is grounded. And same thing we have to verify for the all the gates, 1, 2, 3, 4. All the gates we have to verify. We should get the results as 110, 110, and 110. Okay. This is the actual IC of the NAND gate 7400. Next gate we are moving to NOR gate. The NOR gate is actually a series of OR gate with a NOT gate. Its output is 0 when any or all the inputs are 1. If any one of the input is 0, 0, the output is 1. This NOR gate is inverse of OR gate. I think you have seen in OR gate only at 0, 0 we are getting 0, all other case we are getting 1, but is inverse of OR gate, that is 1, 0, 0, 0. And this is the pin configuration. The slight change in the pin configuration is there. In the earlier diagram, pin diagram, the 1 and 2 are the inputs and 3 is the output, but in NOR gate it is slightly changed. Here 2 and 3 are the inputs and 1 is the output. Same thing for 5 and 6, 9 and 8 are the inputs, and 11 and 12 are the inputs, and 13 is the output. But the 14th pin and 7th pin remains same, means plus VCC, and 7 is the grounded. Okay, and this is the actual IC of the NOR gate, that is 7404. Okay.